Okay. Under event A, everybody put the stuff that's only in A, which is the numbers 2 and 3. Did I do that right? Are those the ones that are only in A? Yeah. What are the ones that are shared between A and B? 4 and 5, thank you. And what's only in B? 6, 7, 8. And is there anything outside of it? Yeah, 9. Okay. Can you map that out on the other Venn diagram too? We're going to show a couple of things, and we have to have 2 copies of the Venn diagram to see this. All right, so for some weird reason, I didn't put the number 1 in here, which means there's actually only 8 items. Okay, so just make a note of that. So let's start, before we teach something new here, let's just start with a little review. What's the probability of A and B? 2 out of 8. Everybody cool with that? So the probability of A and B is 2 out of 8 because there's 2 items in the middle and there's 8 items total. Okay? What's the probability of A or B? 7 out of 8, right? Because how many items are in the circles? 7 of them. Okay? We're going to ask something new now that allows us to do this thing called conditional probability. You see that little vertical bar where it says P A bar B? What does that mean? This means the probability of A given B. Or the better way to say that might be the probability of being in A knowing that you're in B. In other words, the set of B is the denominator. So here's what I mean. Of this whole region, in other words, this is the region that we're looking to for our sample space. How many of those items are in A? 2. So the probability is 2/5. Yeah, that thing means given. That means like A given B. Or what's the probability of being in A knowing that you're already in B? So B becomes the sample space. So it's like we're shrinking the sample space. So let's do that right now. So what is the probability of B given A? Good job, 2/4. You got it. Good job. Because it's of the things in A, how many of them are also in B? So it's 2/4 for that answer. Okay? A real common way to do these problems is this one of these little like tables. Yeah, 2/4, 1/2, doesn't matter, whatever. Okay, so we're going to fill out this table and we're going to answer a bunch of questions based on the table and some probability. Because only 2 items within A are also in B. Right? It's these 2 items right there. Okay? All right, let's make this table. A census of GBS students was taken. Of the males, 50% said they liked the cafeteria food, and of the females, 40% liked the cafeteria food. The population of GBS is 3,000 students, and the male population is 48%. Fill in the two-way contingency table with the given information. Okay, right away we can put 3,000 down here, right? That's going to be our total. Now, how many males are there? 48%, right? So 0.48 times 3,000 gives us 1440. This is the number of males. And then females is going to be 52%. So 3,000 times 0.52, that gives us the number of females, 1,560. Okay, so now it says of the males, so of the 1,440, half of them like the food. So that's 720, which means half of them don't like the food. And then of the females, 40% liked the food. So 1,560 times 40% gives me 624. And then the other set, which would be 60% of that. So what's that? 1,560 times 60%. 936 don't like it. Oh yeah, you could subtract. You're right. You could take 1,560 and take away the 624. All right, now we just have to total down. Can we do that in our heads? Good job. 1,344 and 1,656. Good job. Okay, so now without my help, I think that you guys can do A through I. No, A through H. So I want you all to try with your partner A through H. Do that bunch because that's stuff that could be like on today's quiz. Then after that, we'll talk, okay? Give it a shot. Do them just all as fractions, and don't simplify your fractions. Just do it the easiest way.
Are we gonna have to simplify on the test?
Yes, but you'll have a calculator. All of your denominator should be 3,000. Yep, I'll explain why in a minute.
It doesn't say
What are you doing? You're multiplying? Yeah, you shouldn't. You don't need to multiply. Yeah, just go. No, stop at H. Don't do I. Wait for me on I. Well, try it if you want. I mean, if you think you can do it. All right, so let's read I. Yeah. Yes, you can use that for the test. Okay, so is a female. What is the probability that the person is a female given that the student likes the cafeteria food? What do we do? Yes. It's a 3, sorry. It's just a sloppy 3. It should say 3,000. Okay, go ahead. Yeah, good job. When it says given the student likes the cafeteria food, that's our, that's our denominator. When I say given the student likes the cafeteria food, our denominator now becomes the people who like the cafeteria food. And then the numerator is the females in that category. So it's 624 over 1344. That's conditional probability. It's where we take the whole population and we shrink it down to say something about a smaller group of people. So let's do J. Is a male given the student likes the food? 720 over 1344. Good job, right? Because of all the people who like the cafeteria food, being a male, 720 of them are male, okay? Is a female given the student dislikes the cafeteria food?
936 over 16.
You got it, easy, right? 936 over 16, what's that number? 56, thank you. Is a male given the student dislikes? 720 over 1656, right? Now we switch it up. Likes the cafeteria food given the student is a female. No. Of all the females now, right? How many like the food?
24.
Yeah, 624. So it's going to be 624 over, what's the female number again? 1560. So whenever, look what you see. Whenever you see given something, that means that that's our denominator. Okay? So likes the cafeteria food given the student is male. That's right, 720 out of 1440. And then dislikes cafeteria food given the student's female. You got it. That's right, 936 over 1560. Okay? All right, 10 more minutes and then we will get ready for the quiz, okay? Turn it over on the back. Now we don't have a table. Now we have to talk about some formulas, okay? Oh, no, sorry, the second page, yeah. I don't mean the back of the packet. Okay, it says find the probability of A given B and the probability of B given A, but we are just given these numbers and we're not given like a Venn diagram, we're not given a table. So what we want to do is just make our own Venn diagram to understand this. So draw a little set of circles big enough that you can put the numbers inside, okay? What is the thing I know I can put in without any work? A and B, good. 0.25 goes in there, right? Okay, now, the other pieces of the Venn diagram, the part that's only in A is 0.7 minus 0.25, which is 0.45. I just subtracted, right? I took 0.7 minus 0.25. And the part that's only in B is 0.4 minus 0.25, or 0.15. So when I'm asked for A given B, let's talk about that. A given B, that means that of all of the people in B, in other words, out of the 0.4, I'm interested in how many are also in A. So what should be in our numerator? 0.25, exactly. So we don't care what that simplifies to. We just care about what we just saw appearing in the numerator and denominator. This means that the probability of A given B is the probability of A and B over the probability of B. Did you catch that? That's what those numbers are? In other words, you really don't even need a Venn diagram. You just need to know that when it says A given B, the denominator is the B group and the numerator is the and. And so if I reverse that, if I were to say what's the probability of B given A, it's the probability of B and A, which is the 0.25, over the probability of A. Okay, so do B then by yourself. Find me the probability. You have two answers you need to give me. Find the probability of A given B and find me the probability of B given A.